Good day and welcome to today's physics class. Our topic here says equations of motion. Alright, so we're actually talking about linear motion. So we made us understand that motion is a change of the position of an object with respect to time. Alright, now for us to be able to understand equations of motion, you must know what is called velocity. You must understand the concept of velocity, acceleration. So, to understand the concept of velocity, acceleration, then of course you must know your time. All right. Then we are talking about what distance, or as well as what displacements. Okay. Now, let's take it one by one before we delve into the equations of motion. We'll talk about velocity. Velocity is a vector quantity. It's a vector quantity which is a measure of the displacement with respect to time. That is to say, our velocity is equal to displacement, which is your d over what t. That is displacement over time. Meaning that the velocity of an object is a measure of that displacement. Displacement is a distance that is traveled in a specific direction. So it means that when a car moves from one point A to point B and decides to change the direction to another point, so the displacement now will be that particular point where the car is, then compare it to the one it started the journey from. So that is talking about what displacement. So the velocity now is the measure of that displacement with respect to time. The time it takes for that an object or a particle to cover that displacement. That talks about what? Your velocity. Good. Now, acceleration. Acceleration is now the change of what? Velocity with respect to time. A particle will have an initial velocity, u. That is our initial velocity. Then, when the velocity increases, we say that what the object accelerates with respect to time. Meaning that what my acceleration, it has to be what? The differential of what? This with respect to time. That is the final velocity minus what? The initial what? Velocity gives you the what? Acceleration. So acceleration is a vector quantity. It is saying that what? Velocity changes with respect to time. So on the other hand, when an object or a particle which has an initial velocity, let me say initial velocity which is equal to 0, then the object increases at a given interval after time t. So the velocity that we are going to have becomes the final velocity. So how do we get it now? It has to be that this velocity increases with what? At. Okay. So this is the concept of velocity. All right. And acceleration. So acceleration and velocity, they are interrelated. There is a connection. So when the velocity increases with respect to time, it means there is what? An acceleration. It means that the body is said to be what? In motion. So that's about that. So this will be very helpful in our what? Equations of motion. We have taken note of that. So since we already know that distance now and displacement, distance is a scalar quantity in the sense that what? It only has magnitude. It has just magnitude but no direction. It's just, for example, if I have point A, let's say point A, an object moves from this point A to point B. This is just what? A distance. Let's call here x. This talks about distance. So there is no displacement here. It does not have direction. Now, if this object decides to move from this point A and change direction to this point C. Okay. Now, what is now the displacement? This is point C. The object is now here. At a point, it started from here. So it comes to this point. It gets to B, then comes to point C. So the displacement is not just from here to here. This is the displacement measured from what? The original position to this place. So there is now the displacement. That is what displacement is talking about. Okay, so having known the concept of velocity and acceleration, so we can be able to determine or derive the equations of what? Motion. So the first one, we know that what for a particle which has an initial velocity u, then at a given time interval, the velocity will have to increase with at. So from the concept of acceleration, we have our a equal to what? V minus u all over what? T rather, all over what? T. That means the final velocity equal to a final velocity now minus what? Initial velocity all over what? The time. Okay, this is for acceleration. That is what? V minus u all over what? Or t. If we cross multiply, we're going to have what? V minus u equal to what? At. Alright, now let us get the final velocity of that particle. So moving at what? This acceleration. So the v, which is the final velocity, will give us equal to what? U, this particular u, will to move to this other side, plus at. So this one is equation 1 that we all know. So this is our first equation. So let us look at equation 2. For a body that is uniformly accelerated, we'll talk about uniformly accelerated. It means what? A motion that begins with what? Velocity equal to 0. So at time 0 and at velocity what? U equal to what? 0. It means what? The body starts from what? 0 velocity. That is what the initial velocity is, was 0. Now we make x as what? The distance now that this body will cover after time t. So the distance that the body will cover after time t is given by what? Average velocity times time. Okay, now this distance x, it means what? After time t, when the particle moves or accelerates to a particular what? Reference point. So we then say that okay, this distance is given by what? Average velocity times what? Time. How do we calculate average velocity? Average velocity is given as, that means s will become equal to what? The initial velocity plus the final velocity, which is what? U plus v, or final velocity plus or initial velocity, then all over 2. Okay, times our time times what? T. Okay, now we can call this one equation 2. Yes, this is very important. We normally use this when we want to use the motion of objects under the velocity time graph. We normally use this one. That is the distance now after what? A particular what? Time t. So this is what? Equation what? 2. Okay, now from here we can be able to determine the third and fourth equation. All right, let us go back to our equation 1. We have v equal to u plus at. All right, if we decide to come and plug it into this expression here, let us plug it here. Bring this your v here, replace it with this. All right, so meaning that what? At the end of the day, I'm going to have my distance now, s, equal to what? This your u plus, we have v, replace it with this, because u plus at, everything over what? 2. All right, over 2, then multiplied by what? T. This t that is there. Okay, now let's go further. Here we can have, here we have u plus u here. Okay, so it means that what? My s can be equal to 2u. Okay, are we together? 2u. Now u plus u is what? 2u. We have plus at, everything over 2 times t. Okay, so this t is multiplying everything. So meaning that what? S is not equal to, going to have t will multiply everything. You're going to have 2u plus at all over what? That is t times this t all over what? 2. Everything is divided by 2. 2 is distributed to all of them. So now let us multiply by this t. So mean that what? S is now equal to, we have 2ut plus t times this will give you what? At squared. Everything over what? 2. Okay. Now what this means is that what this 2 in mathematics, it means that 2 is distributed to this and also distributed to this. Meaning that what? I have to divide this by 2, also divide this by 2. So my s is now equal to 2ut over 2 plus at squared all over what? 2. Alright. No, so at the end of the day, these 2, we cancel these 2 out. So mean that what? I am going to be left with what? S is now equal to ut plus half at squared. So this is our third equation. See that now? So our first equation is this. Then second equation is this one. Then what this one is the third equation. So how do we get the last equation of motion? So we can get it by substituting from this first for this place. Okay, from this place we can do that. Let us prove the fourth equation. So from here, how do we prove that? I am still going to make use of this to prove it. Well, in this our equation 1, let's consider making t subject of the formula. So which means that what? I have my v equal to u plus at. Now let's make this t subject of formula. If I decide to come and plug it here, then I can get my fourth equation. So if I want to get t now, it means that what? This now imply that what? At is equal to v minus u. Alright, so just move this one to come on this side, then change the sign. So change the direction. So now I can get my t to be equal to what? V minus u all over what? A. Good. So now let me come and plug this one into this our general distance formula. Now we have that what? S equal to what? V plus u all over 2, then multiplying t. Okay, so now let's bring this now, multiply it here. So mean that what? My s is now equal to what? V plus u all over 2, then multiply by what? V minus u all over what? A. All over A. Good. Now, in mathematics, this is a numerator, this is a numerator. Let's open the bracket. When I open the brackets now, I am going to have my s. Open the bracket, I'm going to have my s, v plus u, into what? V minus what? U, all over, everything all over what? 2a. 2 multiply this. Okay. So now let us open this bracket. This one is just like difference of 2 square. Alright. Just like difference of 2 square. In mathematics, when you have, you look at v plus u here, v minus u. It's just a difference of 2 square. Because if you open this bracket now, you are wasting your time more. You're just making the work to become more rigorous for you. So just have that. This is sitting and saying s equal to what? U square, okay, v square rather. We have v square minus what? U square. All over what? 2a. Okay, that's what this means. Because of this, what is up here. Then, now let's cross multiply. Remember, I want to get my what? The final velocity now. So the velocity after they have traveled through a distance. So now, we have here, we cross multiply, I will have v squared minus u squared, okay, equal to these 2 multiply x, become what? 2ax. Alright, then you can just make a v so you have a formula. Here we have v squared equal to what? 2as plus u squared. So you can write it in a standard form, which is v squared equal to u squared plus 2as. This is our last equation. Equation what? 4. So this is how the equations of linear motion are what? Derived. So you can also call them kinematic what? Equations. So equation 1 is this, while this is equation 2. Then we have this one equation 3, and this is our last equation. So that's all about now. So in our next video, I'll go to show us how to make use of these equations to solve problems on what? Linear motion. If you find this class very interesting, please do not hesitate to share this video. Also do well to subscribe to my YouTube channel. Bye.